the last two solid principles that complete the picture: interface segregation and dependency inversion. These are what make your code truly flexible and testable. Interface segregation plus dependency inversion. Low-level design, day 4. The interface segregation principle says no client should be forced to depend on methods it does not use. Imagine you have a worker interface with 3 methods: work, eat, and sleep. A human worker can do all 3. But what about a robot? A robot can work, but it cannot eat or sleep. If robot has to implement the worker interface, it is forced to implement eat and sleep methods that either do nothing or throw errors. That is a violation of ISP. The fix is simple. Split the FAT interface into 3 smaller ones: workable with a work method, eatable with an eat method, sleepable with a sleep method. Now robot only implements workable. It is not forced to depend on methods it does not use. Let me show you the code. The bad version has a single worker interface with work, eat, and sleep methods. Robot implements worker, but its eat and sleep methods just panic because a robot cannot eat or sleep. That is terrible design. The good version splits worker into 3 interfaces: workable, eatable, and sleepable. Robot only implements workable. Human implements all 3 by composing the interfaces. When you need a new type that can work and eat but not sleep, you just implement workable and eatable. No forced dependencies. This is the essence of interface segregation. Many small, focused interfaces are better than one large, bloated interface. The dependency inversion principle says high-level modules should not depend on low-level modules. Both should depend on abstractions. What does that mean in practice? Imagine you have an order service that sends notifications after placing an order. If order service directly creates and calls an email sender, it is tightly coupled to email. You cannot switch to SMS or push notifications without modifying order service. DIP says to put an abstraction in the middle. Define a notification sender interface with a send method. Order service depends on that interface, not on email sender directly. Now you can inject email sender, SMS sender, or push sender at runtime. The high-level module, order service, depends on the abstraction, not the concrete implementation. In the bad version, order service has a concrete email sender field. It directly calls email.send. If you want to switch to SMS, you have to modify order service. That is tight coupling. The good version defines a notification sender interface with a send method. Order service holds a reference to this interface, not to a concrete type. At runtime, you inject whichever implementation you need. This is dependency injection, and it comes directly from the dependency inversion principle. The key benefit is testability. In your unit test, you can inject a mock notification sender instead of a real email service. 3 real-world examples. First, the printer problem. A multifunction device has print, scan, and fax capabilities, but a basic printer only prints. If you force it to implement a fat multifunction device interface, it has unused methods. Fix it with ISP. Separate printer, scanner, and fax interfaces. Second, the repository pattern. Your service layer should not depend on a specific database. Define a user repository interface. Implement it with Postgres repository, Mongo repository, or in-memory repository. Service depends on the interface. You can swap databases without changing business logic. Third, testing. DIP is what makes your code testable. When your service depends on interfaces, you can inject mock implementations in unit tests. No real database, no real email service, just fast, isolated tests. Here are the interview questions. For ISP, they will ask you to design a multifunction device. The answer is separate printer, scanner, and fax interfaces. Compose them as needed. Another question is designing user permissions. Create reader, writer, and admin interfaces. A read-only user only implements reader, not forced to implement write or delete methods. For DIP, they will ask how to make code testable. The answer is depend on interfaces and inject mocks. They might also ask how to switch from MySQL to Postgres. The answer is the repository interface pattern. Your service never touches SQL directly. Swap the implementation with zero changes to business logic. The pro tip is that DIP is why dependency injection frameworks like Spring, UberFX, and Wire exist. 5 things to remember. Interface segregation means no client should depend on methods it does not use. Split fat interfaces into small, role-specific ones. Dependency inversion means depend on abstractions, not concrete implementations. Dependency injection is DIP applied at the framework level. And with today's lesson, you have completed all 5 solid principles: single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. These 5 principles are the foundation of clean, maintainable, and testable code.